Okay, for the continuation of the our previews or part 1 of our video. So we are still under the theorem number 1. So the radical or root theorem. So this theorem states that if n is a positive integer, the limit of the nth root of a function is just the n root of the limit of the function, provided the nth root of the limit is a real number. Thus, it is important to keep in mind that if n is even, the limit of the function must be positive. So the limit of n root of f of x is as x approaches c is equal to the n root of the limit of f of x as x approaches c, which is equal to the n root of that limit. So once again, if our n here is an even number, the limit inside the radical sign must be a positive number. Otherwise, it will become an imaginary number. Okay, so the limit of f of x as x approaches c is equal to 4. So the limit of f of x as x approaches c, so the square root of 4 is equal to 2. Next is the limit of f of x as x approaches c is negative 8. Then the limit of cube root of f of x as x approaches c is equal to cube root of the limit of f of x as x approaches c, which is given here, negative 8. So the cube root of negative 8. So since the n here is an odd number, so it's okay that we will have a negative number in our limit inside the radical sign because we will have a value for this one. So the cube root of negative 8 is equal to negative 2. Okay, so let's apply the limit theorem number 1 to our limits of algebraic functions. So example, limit of 2x plus 1 as x approaches 1. So using the theorem number 1, addition or subtraction theorem, so we will have the separate individual functions for 2x and 1. So limit of 2x as x approaches 1 and the limit of 1 as x approaches 1. Next thing, since we have a constant here together with a variable, so we will use the constant multiple theorem. So we will separate the constant, which is 2 times the limit of x as x approaches 1 plus the limit of 1 as x approaches 1. Next thing is the limit of x as x approaches c, which is equal to c. And this is what we are referring for. The limit of x is the value of c, so which is equal to 1. So 2 times 1 plus the limit of a constant is the constant itself, so that's 1. So 2 times 1 is 2 plus 1, this is equal to 3. So another example, limit of 2x cubed minus 4x squared plus 1 as x approaches negative 1. So using the theorem number 1, I will use the addition or subtraction theorem and get all the individual functions. So the limit of 2x cubed as x approaches negative 1 minus the limit of 4x squared as x approaches negative 1 plus the limit of 1 as x approaches negative 1. So the individual limits of a function. Next, since there are constant here, so we will just separate it to the variable x. So 2 times the limit of x cubed as x approaches negative 1 and minus 4 times the limit of x squared as x approaches negative 1. That's for constant multiple theorem. Next is the power theorem. So 2 times the limit of negative 1 cube. So by the way, we use the limit of x as x approaches c, which is equal to negative 1 here. So 2 times negative 1 cubed minus 4 times negative 1 squared plus 1. So the limit of the constant is equal to the constant itself. That's why it is equal to 1 here. So 2 times negative 1 cubed minus 4 times negative 1 squared plus 1. That's equivalent to negative 2 minus 4 plus 1, which is equal to negative 5. Okay, so the limits of polynomial, rational, and radical functions. So example, the limit of 1 over x as x approaches 1. So that's limit of 1 as x approaches 1, and the limit of x as x approaches 1 according to the division theorem. So we will just divide the individual limit of the function in the denominator and the numerator. So that's 1 over 1, which is equal to 1. So evaluate limit of x over x plus 1 as x approaches 2. Let's check the denominator first. So that's limit of x plus 1 as x approaches 2. That's limit of x as x approaches 2 plus limit of 1 as x approaches 2. That's 2 plus 1, which is equal to 3. So our denominator here is not equal to 0. So we can proceed on solving the rational function. So the limit of x as x approach, limit of x over x plus 1 as x approaches 2. So the limit of x as x approaches 2 is the value of c. So that's 2 over what we have get here already. So that's 2/3. So the limit of x minus 3 as times x squared minus 2 over x squared plus 1 as x approaches 1. Let's evaluate the denominator first. So the limit of x squared plus 1 as x approaches 1, that's individually x squared, which is 1 squared, so 1. And then limit of a constant is the constant itself, that is also 1. So 1 plus 1 is equal to 2, which is not equal to 0. So we can proceed on solving the rational function. So, the limit of x minus 3 times x squared minus 2 all over x squared plus 1 as x approaches 1, we will get the individual the limits of the functions in the numerator and the denominator. So, the limit of x minus 3 times x squared minus 2 as x approaches 1, and limit of x squared plus 1 as x approaches 1 in the denominator. Next is the multiplication. We will multiply the individual limit here of x minus 3 and the x squared minus 2. And applying the addition or subtraction theorem for the x minus 3. So limit of x as x approaches 1 minus limit of 3 as x approaches 1 times limit of x squared as x approaches 1 minus limit of 2 as x approaches 1. So that's it. So we will get all the values here. So the limit of x is the value of c, which is 1. The limit of the constant is the constant itself, which is 3. So 1 minus 3. Limit of the x is the value of c. So that's 1 squared, which is 1 squared here. And the limit of a constant is the constant itself, which is 2. And the denominator, limit of x is the c. The c here is 1, so that's 1 squared. And the limit of a constant is the constant itself. Again, this is 1. So 1 plus 1. So 1 minus 3 is negative 2. And then 1 minus 2 is negative 1 over 1 plus 1, which is 2. So negative 2 times negative 1, that's positive 2 over 2, which is equal to 1.